Okay, sorry about that, everyone. I'll go over. I went and copied it. Copied the whole setup. Yeah, here we go. Whoa. That's odd. So this goes to up here. With any luck, it copied correctly. I've heard stories of sometimes stuff won't copy correctly and then you have to redo stuff. So now when you press this, you can see it's twitching a little bit, but it's not doing anything. That releases it, and then it goes back. So then you want to slide it, it locks, lets go, it doesn't break this time. I think that's because, let me see here. Yeah, see, I had the strength toned down just a little bit. That actually does make a fair amount of difference. I basically put the strength back to 7.5 and slowly turned it up until it could slide past this pressure. But you can see the little light. Let me plug that in. The light isn't on, and then hit that and the light's on, and it stays on. But when you hit the reset button, it undoes itself. So that's an example of mechanical memory, where something moves and another thing locks it in place. Now then, I want to show you a kind of advanced concept. This you could learn without learning logic. You just need to know true and false. This is more of just like a toggle switch, sort of. I think it's called delatch memory. Now then, there's another thing that you can make that is actually a lot more advanced. And watch the fun. We die. Oops. That's logical memory. Now then, logical memory is a fairly advanced concept because we're going to use multiple logic gates to do one thing, basically. Basically, what we're going to be doing is we're going to be creating a... Whoa, oh my god. Whoops. Whoa, okay. Ow, that's really hot. I had a battery pack right next to me from my stepper motor video, and I guess the leads were touching because the entire casing, like, most of it's melted. Jeez. Ah, dude, it's really hot too. Oh, I'll have to go and get another one of those. Great. Well, goes to show not to stop paying attention to things. Alright, oh well. Alright, hold on. Alright, well, I'm going to pause for just a second, because my food's here, and I need to see if this is still even working. Jesus. I did not mean to do that. Ow, it's still really hot. And yeah, I'll be back in just a little bit, and we'll finish up this tutorial. Okay, I'm back. I went and got some food, so that's why everything's kind of moved around. If I remember right, we were on logical RAM. And what logical RAM is basically you're going to take a bunch of logic gates, and I'm sorry if I'm repeating myself, but I can't remember back this far. You're going to take a bunch of RAM, and you're basically going to create a feedback loop within itself. And then there's going to be a button that when you hit it, it's going to break that feedback loop, and then it's going to cancel itself out. So just think of it that way. You're basically going to have a 1 looping around in a circle, and when you hit a button, it's going to break that loop. So then it outputs a 0 again, and that will be the reset function. And the input is just when you input a 1, it'll go into that loop, and it'll spin around inside that loop for a really long time. And the quickest and easiest way I've found to do that is with 1 OR gate, 1 AND gate, and 1 NOT gate. I know that really doesn't mean much right now, but I'll show you how it works. So I have all my stuff saved in my in the My Objects section. I'll build it. This one right here is the completed version of it. So if mine doesn't work, I'll just pull that one out because I know this one works. Okay. So I was saying I need 1 2 input AND gate. One 2 input OR gate. Pause that real fast. And one input NOT gate. Just like that. Also, I'm gonna need something. I'll build it real fast. I call it an output inverter, or an output changer, or a state changer. I don't know, however you want to call it. But what it basically does is, traditionally, on these outputs, I'm going to have to change all the outputs on the key switches of these to not be on-off. They need to be directional. But the last output needs to be on-off. The only problem is the last output is going to cycle back in on itself. So we need a special changer right here that I'll make just real fast. Oops, that's really thick. Made that one way too thick. There we go. Ah, I'm sorry. I keep on making it too big because I'm not thinking straight. There we go. Okay. Oh, whoops. I need to bring that down all the way back to where it's going to end up. Whoa. This is how you basically make it. It's pretty much the same thing as a NOT gate, only just a little bit different. Oops, wrong one. And on that one, you want it to be on-off. That's what the output's going to be. Alright, so let's wire this thing up. Okay. So, our input is going to go into our OR gate. Oh, yeah, let's make the switches real fast, since now that I'm thinking about it. There we go. This left side over here is going to be our reset. And the right side is going to be our input. Okay, so the first thing is we need to think of how this is going to work loop-wise. These two things right here are going to generate the loop. So you're going to get an input, it's going to come over here, it's going to go into here, it's going to output through here, and it's going to come back into here, and it's just going to make this huge loop. A continuous loop. Then this output's going to go over here and be turned into a on-off output instead of a directional output. So that's what we need to do next for all of these except for the one on the left. These all need to be directional outputs because we're going to be controlling a piston with each of these, not on-off. Otherwise it'll just spam back and forth. Okay. So, this is how it's going to work.